Hey, welcome into This Week in Radio Tech. I'm Kirk Harnack, glad to be here with you and glad that you're here with me. Well, this week we've got a really special treat for you. You know, a couple weeks ago, we were in New York City, and 3 weeks ago we covered the fact that the Master FM Antenna system on the Empire State Building was going to be 50 years old. And 2 weeks ago, we actually did a live broadcast from a rooftop bar right next door to the Empire State Building. We talked with a number of guests who were going to be speaking later that night about the 50th anniversary, and we watched the light show that was put on at 7 p.m. Eastern Time in New York City in celebration of that 50th anniversary. Well, after we left that rooftop bar, there was an hour-and-a-half seminar that went on with really fascinating speakers, hosted by David Bialik and Scott Fybush. But there was a fantastic bevy of speakers talking to us about the history of FM broadcasting from the top of the Empire State Building. So we looked at some radio history, we heard jingles and broadcasts from almost 50 years ago and through the decades. And we also learned a lot about the engineering of the master antenna system on the Empire State Building, both the original Alford antenna, which is still there and it's available for backup, and the newer antenna systems that are up there. So Tom Silliman from ERI gave us some big, in-depth information about those. Bob Tarcio was there, part of the design team for the newer antennas. So it was really, really fascinating. Well, guess what? We videotaped that for you. We edited it up just a little bit to put lower thirds on, let you know who's speaking, and we're going to present that fabulous seminar to you on this episode of This Week in Radio Tech. Now, there won't be any commercial interruption during the actual episode, so if you would, pay attention for a couple of announcements right now. I want to tell you that our show is being brought to you by the folks at Axia. Axia and Livewire Plus, which now is compatible with AES 67 audio over IP. Axia and Livewire have so many partners. It's just amazing. We don't usually talk about the partners, but so many companies have joined in with Axia and the Livewire Plus protocol to make audio over IP really easy for you. Some examples of the companies that their products just plug in and work with Axia. French company, A2Z, ABC, AEV, Avra, Axel, Broadcast Electronics, BSI, Burley, Dabis, David, Dalet, Digimedia, Digispot, Digiton, Enco, Fraunhofer, Hardata, Innis Corporation, Nautilus, Netia, Nextcast, OpEx, OMT. Yeah, these are all automation systems I'm listing off here, but they kind of top the list of the large number of partners. Rivendell, RCS, Pristine, Sterlitz, Synodon, VoxPro, Wide Orbit, Win Media, WireReady, and Xenon Media. Then there's hardware development partners like Digigram, Audio Science cards, Logitech, Maya, Force Omnia, Paravel Systems, Radio Systems, Ravenna, Sound4, Studer, Telos, Wegener, XI Audio, Nautel, on and on. And system integrators. There are worldwide system integrators that are just experts at installing and designing Axia systems like IP Studio, CSS, BV Media, AVC, Pippin, R-Barth in Germany, Tract, Triple Audio. Just the list goes on and on. This list is all available at the Telos Alliance website. I just want to point out that I think that's close to 70 partners altogether, companies that have agreed to work with Axia and Livewire to make your job, to make my job too, as an engineer, a lot easier. Just plugging these things together and configuring them and letting the audio flow, and GPIO in most cases too, flow between different pieces of equipment. So thanks to Axia for sponsoring This Week in Radio Tech. You can always find out more at telosalliance.com. Look for the Axia logo and plenty of white papers, videos, and things like that to bring you up to speed on audio over IP. Another sponsor of our show, and I told you we'd have no commercial interruptions during our hour-and-a-half seminar, so that's coming up. Another sponsor is the new ZipStream line of audio processors and streaming encoders from the Telos Alliance. And the newest product is the ZipStream R2. It's a one rack unit box. We actually showed it here about a week ago on this show. It's a beautiful one rack unit box, and it has 8 program inputs, either by live wire or by AES digital. It also has program outputs, so you can just do audio processing and bring that audio straight back out if you want to use the audio processing capability in there. But you can also do stream encoding and a wide variety of different types of streams for the kind of streaming that you want to do or the kind of streaming that your listeners want to pick up. But the newest thing that's in there is Apple HLS streaming. Now, there's also Microsoft Smooth streaming. That's available in there too. But Apple HLS has been the subject of a lot of webinars and SBE meetings here lately. It's built right into the ZipStream R2. The audio process that's built in is pretty amazing too. Now, it comes standard with a 3-band Omnia audio processor with fantastically designed look-ahead limiting. It is perfect for streaming. But if you want to really, really hit the top, it also is available with Omnia 9 audio processing from Leif Clayson. And Leif has been doing this for years and years. The guy is just really sharp. And he's got some fantastic algorithms, including undo and the declipper that are built into the Omnia 9 processing. That's an option you can add on to any or all of your streaming encoders with the ZipStream R2. The ZipStream R2 is also compatible with Triton protocols. So if Triton is your CDN, and they add a lot of value with commercials and stream counting and just taking care of all kinds of things on the business end and getting your stream around the world. We have all those protocols built in as well. The ZipStream R2, check it out if you would at telosalliance.com. Look for ZipStream. There's a whole range of ZipStream products, software and hardware both. They are your new transmitter, and the ZipStream R2 is quite a substantial one. And finally, our third sponsor is Lavo. Lavo makes big audio consoles for installed sound, for television. They make surround sound consoles, but they also make a line of smaller radio consoles. And their newest one is the Crystal Clear console. It's a virtual radio mixing console. What does that mean? Well, it means the surface that you play with, that you actually do your mixing on, that you touch, is virtual. In other words, it's not hardware. It's hardware. It's a computer, and it's a multi-touch touchscreen interface. But it's you can plug it in the network anywhere and control the actual inputs and outputs in the mix engine, the Crystal mix engine. It's an amazing product, especially this idea of a touchscreen. And if you want to, if you need to go to your office, yes, it's possible to unplug this thing from the control room and pick it up and take it to your office and plug it in there and do your radio show from there. Yeah, you'd have to move a microphone or two, but you have access to all the mixing going on right there. You can even remote in from home, and of course, most systems let you do that nowadays. But it's just so cool that you can run this app and have multi-touch touchscreen. The Crystal Clear mixing engine itself, it's a 1-rack unit box. Goes in the rack. You plug all your inputs and outputs to it, whether they be microphone, analog, AES digital, or even Ravenna and AES 67 audio over IP. All that's built in to the Crystal Clear mixing engine. Dual power supplies available too. It's just a really neat concept. Check it out if you would at Lavo. That's spelled LAWO.com. Lavo, LAWO.com. Thanks to Lavo too for sponsoring This Week in Radio Tech. All right, an hour and a half now. Well, an hour and 26 minutes. No more commercials. Let's go to the event. I believe this was on the 67th floor of the Empire State Building, where David Bialik and Scott Fybush get things going to introduce us to the seminars detailing 50 years of operation of the master antenna system on the Empire State Building.
Celebrate and to discuss and learn about the 50th years of the FM Master Antenna, where legendary broadcast engineers have worked. We have legendary engineers on the panel, legendary engineers in the audience. I mean, Frank Foti made his career with the station coming off the Empire State Building right there. And there are many other engineers here that, like the song says, we delivered FM with no static at all to the masses. So that just happened outside, and I don't care what anyone says, this is the coolest night in radio ever. Around 2 years ago at the NAB convention, there was a session on the Empire State Building antenna Peggy Miles, Rob Bertrand, Shane O'Donoghue were on the panel, and they were talking about it. And they made the mistake of having me in the audience, and they really made the mistake of naming some dates. And I said, oh, wow, next time AES is in New York, we have a 50th anniversary. Okay, I can never remember my wedding anniversary, but I remember this. So for the next, Peggy can correct me, but I think we've been discussing this for almost a year now, on getting this all planned out. Shane O'Donoghue was a big help in all of this, and this would not have happened without him and Peggy Miles. So I want to get a big round of applause first for them. I also want to say thank you to the Empire State Building Realty Trust, because, trust me, tonight ain't cheap. That was filmed by helicopters. And I don't know the last time we had an AES meeting with anything to do with helicopters, but I think I reached a new height. And this is the highest the AES has ever been. Bill Sachs, do not fight that. So we're going to start tonight discussing the history and the engineers that have worked here and the technology of the Alford, of the new master, of FM broadcasting, and there will be questions and answers. We're going to have a wireless mic, so we want to get everything on recording. And I also want to thank, first off, Jeff Smith, Jeff Schick, and John Bennett for doing AV tonight. I want to thank Mary Kent for volunteering for photography, Robbie Klein for photography. I could not have put this all off together without a little help from my friends, and no, I'm not going to break into a song. So right now, I'm going to introduce Scott Fybush as the moderator, because you don't want to hear me talk anymore. And I also want to thank Joel Spector for running security tonight. Thank you.
Thank you.
Oh, and I also want to thank Rob Bertrand, because of the time with CBS FM, he was not expecting this, expecting to be involved at all, and boy, did he get involved, and he really came through for us without being asked. So thank you again, Rob.
Thank you all for being here tonight. You are, of course, in a tremendously historic place. Not only are we here for the 50th anniversary of the FM Master Antenna, but upstairs on the 85th floor was one of the places where Edwin Armstrong developed the technology that became FM, so that's kind of a sacred space up there. This is the spot next year where the 75th anniversary of commercial television broadcasting will be marked as well, and the station that was here back then WNBT, now WNBC, is still there. We are here tonight, however, to talk about FM, and think about it. We are all gathered here in this room. Some of us have come hundreds or thousands of miles to mark the anniversary of a bunch of little pieces of metal sticking out from an observation gallery. And I guarantee you, if you've ever been up there when the tourists are up there, you know that they're not particularly noticing the little bits of metal. But I wanted to begin tonight by recognizing a little bit of why those pieces of metal are so important. We're going to talk at length tonight. You're going to hear from the engineers who are involved in the design and the maintenance and the replacement. We're going to hear a little bit about the future. But I want to start just by taking you back into everything that came out of those pieces of metal and the way in which, even though they had no idea what those pieces of metal were, people all over New York City and beyond were moved by what came out of there. So I want to start with a little bit of a presentation of some of the sounds that came out of the Alford over all of its years as the master antenna.
This is WBAI, listener-sponsored radio in New York City. You want me to introduce you like Mike Wallace?
No. I want to
this is Bob Dylan.
Oh,
I can't say who it is? Oh, all right.
WORFM. Call it 1254. This is Johnny Donovan. Got a couple of kind words for New Jersey. Simply thank you for requesting this one from the Bee Gees. You are tuned to WNYC, New York City's own station, and WNYC FM.
Coming up to 2 o'clock here at WNEW-FM 102.7 on your dial, Metro Media Stereo in New York. Allison Steele, the Nightbird. We'll pause now for 5 minutes of late news and weather, and then I'll be back to continue our journey to dawn.
24 degrees and clear at 2 o'clock. This is WNEW News up to the minute. Dave
This is
Merritt.
Mindy Steinberg in the WEVD newsroom, returning you now to the Morning Simcha with Art Raymond.
All stereo music, all the time on Stereo 105 in New York, WRFM.
WBLS New York, Stereo in Black, where you hear Sly and the Family Stone, John Coltrane, Buddy Mott, Roberto Isaac, Marvin.
We heard the Academy of St. Martin in the Fields, led by Neville Mariner.
This is Kristen Booth Glenn, General Counsel to the WNCN Listeners Guild, reading a statement prepared by the Listeners Guild. Today you have heard...
Welcome to our alternative in New York, WQIV FM.
If you want a copy of the Guide to Dining Out, you just send that self-addressed, gently stamped envelope to Cocktail Time, WQXR, New York 10036, New York. That'll do the trick very neatly. Back to our well-seasoned music here at Cocktail Time. Festival music opus 25.
At 9 p.m. when WPIX presents a special on the Stones following their 3-day invasion of New York City. Listen to WPIX FM for all you're worth.
I always do. 222 from Fix. Dayton here, dozing off occasionally.
New York. 99X, making the last summer of the decade your best summer. 7 o'clock, Sue O'Neill. It's time for our regular Wednesday night feature, the official New York music.
20 before 11, 4th of July. Hot hits all summer long, only on 92 KTU. The hot one. This is Roscoe.
Rolling in the park.
WKHK. Well, that spells kick, and that spells the best in country music and fine, fine stereo. Kick FM.
As we kick off another 30-minute commercial-free music set, it's the holiday edition of the National Dance Party right here on 98.7 KISS FM.
My daddy's name is Red and
You're on.
I know.
This is Pete Fornatale at my new radio home, 92.3 WXRK New York, K-Rock.
Jack Weck up next with electric dedications on WHTZ Newark. New Jersey, New York, and Connecticut's new Z100, a Mallrite communication station.
Serving the universe.
Ladies and gentlemen, from the top of the Empire State Building and broadcasting loud, Gio, the freaking Puerto Rican.
And it all came out of there. This was the antenna that took FM to #1 in this market for the first time with WKTU, what you heard there, and took WABC down after all those years. So that's a little bit of the sounds that people heard from it. Now I want to get to some of the technology that made it all possible. Our next presenter pretty much needs no introduction, I hope, to anybody in this room. I assume everybody has seen the famous New York Times photo climbing the tower, looking down from above at him. That's Tom Silliman. Tom will tell you a little bit of his story with the tower and a little bit behind the engineering that went into the Alford antenna and its upgrade and its replacement. Without further ado, I introduce to you Tom Silliman.
Down there?
Just without a spacebar.
Spacebar, okay. Well, it's great to be here, and it's a great honor, and I want to thank Shane O'Donoghue for inviting me. Shane, thank you very much. And I have to say, I've climbed that tower so many times, and John Freck is in the back. John Wary, stand up. John and I have climbed that tower together, I bet 50 times. And the first thing John says is, he says always two things to me. He says, Tom, watch out for the LEDs. And the other thing he always says to me, he says, Tom, people watch you climb. You need to climb perfect. So, John, it's a great pleasure climbing with you all these years. Thank you. Again, it's a great honor to be here. And I don't know that I belong here, but I'm here, so we'll get started. My father, Robert Silman, was a consulting engineer for many years. And during World War II, Andy Alford was at Harvard in the Radio Research Labs projects, and he was figuring out ways to foil Germans, who are our allies today. And one of the things they did was they developed their shredded aluminum foil on D-Day that made the Germans take their radar apart. But they were working together at Harvard, and the problem was that the U-boats were all up and down the East Coast, and they were worried about the fact that the Germans were studying what we were doing. So there's a guy named John Carraway working with my dad, and he said, hey, and I'm rambling, so I hope I don't lose these slides, but Carraway said, you know what, U-boats can't go up the Ohio River to Evansville, Indiana. How about if I start a company there called Electronics Research, which is where I am today, and you can do your tests there. So that's how my dad and Andy Alford got involved. It's hard because I can't see the slides. Thanks. Later on, when I was in high school, I did a lot of work with my dad. They talk about engineers. I wasn't trained to be an engineer. I was unfortunately born to be one of those bastards. And I've been one ever since. And a little aside, I'm a storyteller, but when I was in high school, I flunked the 7th grade, and they discovered in the 4th grade I couldn't read. And so they gave me an IQ test, and they've never told me what the results were. But later on, I flunked the 7th grade, and my dad put me in a Navy prep school. And my dad wanted me to go to Cornell, and they told me I couldn't go there, but I did. But when I was in high school, my dad and Andy were talking about this building. So we built an Empire State Building tower turntable in our backyard, which my mother absolutely hated. And we did pattern measurements to propose an interim antenna on the tower before the Alford went in. And unfortunately, probably, we never got the job. I'm going to talk today about my father. My father did all the proofs for Alford because after the war, my father went to Washington to be a consulting engineer after joining the FCC. And Andy and my dad's lives were entwined until both of them left. And then later on, I actually worked with Fred Abel quite a bit in doing proofs. So all the proofs on the Empire State Building that were done for every station had it. Robert Silman and Fred Abel did those IM product proofs. And of course, Kevin Fisher's here, and his dad, Neil, worked with my dad too. So I'm going to talk about the antenna, the combiners, the method that Andy used to achieve bandwidth. I mean, this guy was so amazing back in 63, 64, before this thing went in. And it's really cool what he did. It's kind of like the way UHF slot antennas work. Slots are very narrow banded, but slot antennas are broad. Why is that? It's because of the slot spacing. Andy figured that out. And I also want to talk about some of the repairs I've done. I'm meandering. My dad in World War II had 32 patents working with Andy Alford in the war effort to defeat Germany. I think we already talked about that, but we worked with Andy Alford after the war and after the Empire. We also did all the proofs on the Hancock building in Chicago, where he built a second broadband system for those stations. And when I was in college, before my master's degree program, I went to Indiana, and we quoted to compete with Andy on the Hancock building and on the One Shell Plaza building in Houston. We quoted 12 bays arrays. We got the Houston job. Andy got Chicago with a 2-bay array because the 12-bay wouldn't fit. But Fred Abel and my dad and I did all the proofs on that building as well. We, the last station that went on, which Neil was not too happy about, right, Kevin? Right, Bob? Yeah. So we got hired by Malrite in 1983. We actually added the last station to the Alford antenna, and we built a notch reflector type filter and put it in for Tom Persanovich. And we discovered some interesting things. But all the proofs that were done on the building were done with a Keir filter. And when I was in high school, I actually worked as an office boy and as an engineer in DC, and I actually met Frank Keir and Kieran Kennedy and all those guys. But Alford worked with Keir and used his filter to do all his ion product measurements. Obviously, later in 1970, my dad would call ERI and he'd say, "Send my son to Chicago. We're going to do a proof with Fred Abel on the Alford system in Chicago." That system is now retired. But what's neat about the Empire State Building is the Empire State Building Alford system is still used today and very often. The Alford antenna has 16 elements around the building. It's 2 levels, 13 feet apart. The 13 feet is based on the building geometry, not the ideal array factor design. And later on, after Andy built that system, the U.S. and the Canadians came up with a Canadian agreement, and the antenna harness needed to be upgraded. So my work in the Empire State Building started accelerating at that time. And for some reason, Andy wanted us to do it. So I designed it, and I came in. And it's kind of funny because Doc Masumia was in charge then, and I told him I could do it in one weekend, and I did it. And he told me later, and Bob, you remember this, he said, "Well, I'm not happy with you." And I said, "What's the matter?" And he said, "Well, I know you did it in one weekend, but it should have taken 2. And I always remembered that. I thought, okay, I learned something real quick. I should have charged more. But we got it done.
Was the array down while you did it?
What's that?
Was the array down while you did it?
Half of it.
Oh, yeah. Yeah, what we did was the Alford antenna is really cool because there's a switch down on the TC floor, was right below 101. And it's a really neat switch. And it's been modified, I think, once. And Andy designed it. It's actually a switch that's a transformer switch, so that there's one feed that comes in, and there's 2 feeds that goes out, and you can take that box open, and you can make the Alford feed the upper bay or the lower bay. So we did that, and then we spent one night doing the one bay, and then the other night doing the other bay, and turned it on, and it worked. And that's how we did it. And that switch is still there today. And when we did it in 1983, they gave us this plaque in 1984, which is in my lobby, which is really cool.
Mine too.
And in yours too. So, I talked about building a model of the building when I was in high school, and this slide sort of talks about it. My dad had bought ERI by then because Caraway, that moved out there during the war, had a massive heart attack and died. And the Collins Radio Company came to my father and said, "We'll pay you to go to Indiana and figure out what's wrong with our antennas." And he went out there and he said, "Well, there's no engineering left. Mr. Caraway's dead. His wife's running it. It's not working." So they asked him if he would buy it. So he went back out. Mrs. Caraway shut the company down, and he bought it. And he said, I just want to own one share over half, but I want local. So two guys went there and stayed. And they were my bosses when I moved out there in 69. The Alford filter is really cool. The way it worked was it didn't use 90-degree hybrids. It used 180-degree hybrids, which Andy had developed. And those of us back in the 70s saw these things all over because in those days they didn't make a 20-kilowatt transmitter. So you'd go to a site to work. I did a lot of field work in those days. And there'd be these two 10-kilowatt transmitters, and they'd go into the side of this thing that was a half-wave long, and there'd be a load on one end and the output on the other, and it was a 180-degree Alford hybrid. They're all over the country in those days, and they're no longer seen today because bigger transmitters are available. But what he did was he had two of those hybrids, the top and the bottom there, and a stub matcher, and then the injected guy would come in, and then the notch would shift the broadband out, but then the one guy would get a 180-degree shift and he would be injected. The downside of this filter, which had 280-degree hybrids, one passband and one notch, was that plus or minus 75 kilohertz, and nobody knew this at the time, but I did because I had to repair one. When I was working with Bob Tarzio, who was my boss then for many years as the project leader, but when we were doing the new FM, one of those Alfords failed, and we took it to Indiana, rebuilt it, and brought it back. And I had the pleasure of measuring it, and I was shocked to see that at plus or minus 75 kilohertz, it had 3 dB insertion loss. And that's probably one of the reasons the new antenna sounded so great. This is actually a picture of one of those filters. They were all in the E floors. So when you go in the building, today the E floors are kind of empty, but in those days you go through and there was all these filters going up and down through the E floors in the building, and they were all the Alford filters.
I change them once a week.
Yeah. I've been many times in there myself. I threw the slide in because I'm a great fan of Mr. Smith's, because I went to college with a slide rule and we didn't have network analyzers, we had Smith charts. So what happened, I'm going to show you this, but if you look at this chart, it's kind of freaky. So you'd have these points up here. And as
Tom, go back on mic. You're being recorded.
Okay, how's this? Does this work?
Yeah.
So let's say you start here. Well, as you go down the line towards the generator, these points are going to run out because 108 is going to go faster than 98 and then faster than 88. So these points are going to blow up. You're going to lose all your bandwidth. So what Andy did, I love this guy. So he would come down when he got about to that point, and he'd roll down a quarter wave, and you could see here that these points are a lot further apart than those points. Then he would add a slug, and he'd jam them up here. Then as you come down, now the high frequency is in the back, and the low frequency is in the front. So now the high frequency catches up. So you can see now you come down another quarter wave or so, and it curls up. That's how Andy did it. That's how he preserved his broadband. And we discovered this the hard way, because when we added that other filter in 1983, we realized his broadport was 10-to-1 mismatch where we were. So we had to fix that problem. And that's when we discovered the game he was playing, which was friggin' brilliant. You gotta love Andy. And you know, the neat thing about Andy Alford, I knew Andy Alford. My dad told me one day, he said, you need to go to Boston and meet Andy because he wants to sell us something. So I flew to Boston, I met Andy. And one thing I can tell you about Andy is, number one, you never called Andy because you were on the phone for the whole day. And I don't know if anybody in here remembers that, but Andy was a talker. And then when you visit him, my dad said, I don't care what you do, just buy something. So I bought the rights to build that filter, and we built a couple of them until we switched over to the newer filters. But I almost missed my plane because Andy took me to the airport, followed me to the gate, and kept talking. And finally I said, Mr. Alford, sir, I've got to get on this plane. Anyway, each bay level of the Alford antenna has 16 elements around. And if you read the papers that he wrote, you realize right away that he figured out that you can't just make this antenna work real well. You really got to work with it. So what he did was, and now I did this later because I built the transformers that are up there today. But what he did was he built the antenna groups in 4, and then he rotated the phase so that each 16 bays had four 4-way power splitters, and each power splitter he rotated the phase 22.5 degrees, so that if you look at the curls, the first curl would be here, second curl would be here, third curl would be here, fourth curl would be there, just like a slot antenna. They sucked up, and if it was just a brilliant design. And if you did this today, everybody say, okay, fine, so what? But you did this in the 60s, this was revolutionary. Each bay is actually fed with a single 6 1/8 feed line, and the 2 feeds are combined using a custom switch down on the TC floor, which is below 101, which the door is now locked. I can't get to it anymore, Shane. And thank you, sir. But the phase rotation is what achieved the bandwidth. And if you read his papers, you can actually see that in there if you dig for it. This is the actual feed schematic for the Alford, and you can see the four-way power dividers. There's one, if you go up above 102, you can see it, and then there's one down below that you can see as well. And they use 1 5/8 flex to feed the elements. And the way he did the antenna back then, he didn't have method of moments or any of that stuff that Harringer from Syracuse invented. So back in the 60s, the only way he had to design this thing, and Kevin Fisher and I have gone round and round about this, was to use a model. So what he did is he used a model to do it. And this is an actual photograph from his paper of the model. And it's a scale model of the building. You can kind of see it. If you look over there, you see the building. And then you look at this, you can see that he modeled the building in a small scale. And he used this thing to measure the patterns. And these are Andy's patterns. They were measured on that model. So when we got involved looking at it for Mr. O'Donoghue and for Kevin for possible use in the future, we did a neck model. And if you go back, if you went back, this is at the center of the band, and you can actually, it models his antenna pretty well. The big thing that he did was he was forced to design to the building geometry. So his base spacing was 13 feet. It's not the ideal spacing. The new master antenna that I built and installed in 1992 and turned on in Christmas of 94, I believe, Bob?
January 94.
January.
25th. Yeah.
And it had a 10-foot spacing. And if you look at the difference, on the left is the Alford design, and you can see what happens when you stretch that bay spacing out. You have a really big grading lobe, so he had some difficulties there. And if you look at the 10-foot spacing, you can see it's significantly less. But he had no choice. He did what he had to do. Later on, when I was working on the news system, they discovered that there was a redundant hose clamp out there on 102. And so there's a little error here in the second or third bullet. They actually, what they did was they asked me if I could get that hose clamp off there, and I said, I think so. So they tied my feet and hung me out the window head first. And
you willingly did this?
Yeah.
And this explains everything.
Yeah. So I hung out the window and I got the hose clamp, and everybody said, yeah. And no pictures, no. And my cell phone fell out of my pocket. And I watched it go down, and it hit down there, and I said, all right, we got to go get my cell phone. And they said, why? And I said, well, if somebody finds that chip, they're going to know it's my cell phone. I don't want to be in trouble with the building. So we went down there and it landed antenna first and it stuck in the roof. So I found it, and I found all the parts, and we put it all back together, and that sucker worked. So I don't know, it was an old phone, it was a long time ago. But anyway, it was successfully completed. That antenna's operated trouble-free from the day it was turned on. That antenna's never had a failure. I mean, that's amazing if you think about it. That antenna is still operating today, all the time, and still reliable. During the construction, when the new FM was done, one of the Alford filters failed, and so twice. So that was here. So he said, "Tom, what are you going to do?" So we took the filter out, and we drove the filter back to Indiana, and we rebuilt the filter and brought it back and put it back in. Did we do it twice?
Yeah. We had 2 burnouts.
It's bad karma.
Yeah. That's when we knew it was time.
It was So anyway, we rebuilt it and shipped it back. And again, we added one station to it later that was Malrite in 1983, and we got in a little trouble for that with Neil, Kevin's dad, stepfather. We delivered and installed it. And it's a funny story because Robert Rose, my VP of engineering, is dyslexic. So when we set the filter up, he reversed 2 of the frequency numbers, and we turned it on, and it looked perfect, and all of a sudden it went pow, and it burned up the dummy load. And I looked at it, I said, "Oh my God, you tuned this filter to the wrong frequency." So we had to rebuild the load and fix it, but it ended up working, and it served until the end of its time. When we did the FM master antenna for the Empire State Building under Bob Tarzio's direction, we modified the Alford feed and ran a new 6-inch line up to that famous switch on TC. And that switch is now connected into the 85th floor combiner room of the Empire State Building master FM antenna. And that switch allows them to operate now. So whenever it turns out if you operate the Alford, you can go out the hatch on 104 and stand on the ice shield, and you're not exposed to RF in excess of the limits. So that's how we go. We like to go out and walk around, and of course there's no safety rail, so we don't really take guests. But you walk around 180 degrees around the building, and there's an old aluminum ladder, and then we go up to the tower, and then we go up. So anyway, that still used today. So anyway, that's my presentation. Thank you for inviting me here, Shane. Thank you very much, sir. And if there's any questions.
We'll take questions later. And I don't know if I thanked before, I want to thank SBE Section 15 for helping out tonight. Jeff Smith went well above to help out and make tonight memorable. Scott?
Thank you. Mike here, so good. Okay, we're going to bring up a couple of the engineers who were involved over the years in taking care of the antennas and a lot of the transmitters who fed them. I want to say a couple of words. Also, so a little bit of unfortunate timing. You heard the mention of Neil Smith, and unfortunately, I don't know if everybody's heard or not, but Neil passed away just a few days ago. We were very much hoping that he could be with us tonight. Neil, for those of you who don't know, worked for Kieran Kennedy from 1964 until 1972, and he was the supervising engineer for the installation of the Alford. You can see a lot of his collection of photos. If you haven't had a chance yet, those are on display, some of his memorabilia and photos and some goodies from the archives here at the building, which are phenomenal, let me tell you. He went into consulting in 1972, worked with ABC, helped them garner an Emmy, and was just a really important name in engineering. And we had, as I say, hope to have him with us tonight. Kevin, his stepson, is here with us tonight, and we extend our condolences, and I hope you'll get a chance to say hello to him at some point in the evening. On that note, I want to move on to Bob Tarzio. Bob, as you heard, was involved very intimately in not the end of the Alford, because it's still up there and still working, but the replacement of the Alford in the 1990s with the master antenna higher up that continues to feed most of those same stations. Bob is now at Broadcast Devices Incorporated. A lot of you probably have his boxes somewhere in your air chains if you run a station. So Bob, if you want to come up and say a few words about some of your time at Empire?
Thank you, Scott. I want to thank Shane for getting this thing together. This was great. I feel like, first of all, it's a tough act to follow, Tom Silliman, number one. But I sort of walked in the middle of the movie. I came to the Empire State Building in 1982, and I got hired to be an assistant chief engineer at what was then WKHK, later on became WLTW. And, first week on the job, the chief engineer who hired me, John Banks, said, well, we got to go up to the Empire State Building. I got to show you around up there, and we got to show you what we do up there. We have 11 stations that are combined together in an antenna. And I come from the suburbs. I worked at an FM station. There was a Gates transmitter and a transmission line, and I went up to an antenna, and it's like, I'm seeing this for the first time. You can actually do that. You can actually put FM stations together on the same antenna. So this was this Alford system. And, I thought a lot about, what about the Alford system that really, Tom touched on some of this. But for me, I like to think of Andy Alford as the pragmatic engineer, because as Tom said, he had this tough job. He was given this aperture, which was the observatory. It's the wrong size, it's too big, and he's got to make an antenna fit in there. And I remember reading the paper, and he started out with, I think he started out with 4 dipoles, and the pattern looked terrible. And so he started adding dipoles, and he's doing this by hand. This was a model that they put together. It was a 10th scale model, and they had to actually hand build this thing and then retest it. And then they finally got to the point where they had this pattern that kind of looked like what we saw up there. I find it fascinating that 50 years later, you're able to duplicate in NEC what he actually did by hand. Slide rules, general radio admittance bridges, no network analyzers, and slotted lines. That's how this whole system was built. So that's, I think, is the genius of the system, is the antenna. And that switch you were talking about is actually a power divider. It's a strip line power divider. Transformer, right. So, and that thing is still used almost nightly when we're doing work up there. So a lot of this system is still with us and still operating. So the other part of it is that we're here at the AES convention. So probably a lot of folks have thought, well, what is this? We were talking about all this RF stuff, and what does this have to do with audio? Well, it has a lot to do with it, because prior to 1965, FM broadcasting in New York was kind of a hodgepodge of stations that had found, a lot of these FM stations were the second stepchild of the AM stations that were dominant in the market. And so they built these stations. They put them on different buildings in town. Some of them were here at the Empire State Building. WNEW up here, that was Scott played a little bit of. They actually were using a part of the batwing antenna for Channel 5 to use as an FM antenna. That's certainly not optimum. So you had all of these FM stations that were doing their own thing with these antennas, and it was the combiner and the combined antenna that really made FM practical and made FM stereo practical. And that's really what spurred a lot of sales of hi-fi equipment. There was an awful lot of interest in FM stereo at that time, and that's really what got it started. So, all right, so we fast forward to 1982, 83, when I come along, and I'm just, one of the guys up there doing the weekly maintenance and all of that. And about a year and a half or so later, I was named chief engineer of what was still WKHK, and then later on it became WLTW very shortly after that. And somewhere along around 1986 or so, we decided we got to do something, because we were having problems with the Alford system. Now let's remember, the Alford system was 2 radio stations when it started. WQXR 96.3 and what was WHOM 92.3. 4 megahertz split, 2 stations on this modified run-out combiner. So very rapidly, that was 1965. By about 1971, The last station before Z100 went on was my station, what was at the time WRVR. There were now 11 stations on this combiner. Yeah, remember WRVR? Yeah, in the Riverside Church. So now we got problems because this system is really, we were putting 10 pounds of RF in a 5-pound bag at this point. So we had to start to look at replacing it. And a big part of doing that was trying to study the Alford antenna and understand how it worked, what its limitations were, and to figure out how to write specs for a new antenna system. So we sat down, and I didn't do this by myself. We had a great group of engineers. Some of them are here tonight that were involved in that. And I had help from, ironically, the 3O&O stations at that time, CBS FM, what was WYNY, which was on 97.1, and WPLJ. The engineers for those stations contributed to our effort, helped out a lot. Alan Parno was with ABC at the time, WPLJ, and Mark Olkowski was with NBC at the time, and Seth Elliott at CBS. They all contributed to helping us. And largely, the guy who I worked with was from Z100. After Frank left, the late Jim Solmich and I sat down across the table and rewrote the specifications for what would become the ERI master antenna. And for me, having to come into this not even knowing how this all worked, and then eventually having to figure out how it worked and learn this, and it weren't for people like Neil Smith and Robert Silliman, who was Tom's dad, who was our consultant, and Tom, and the late Jim Kemen from ERI. What an education I got and heard. I get choked up about this because this was 8 or 9 years of my life getting this done, and it's the fact that we are 50 years later, we're still doing FM broadcasting from the Empire State Building, and I think I honestly think FM has a very, very healthy future, mainly because of what we did all those years ago. There's a lot of everything that's old is new again. Kids are rediscovering vinyl. I read an article last week about analog audio cassettes. The Philips cassette is now coming back into into popularity. Why, I don't know, but it is. But I honestly think that FM radio is going to do the same thing. MP3s are great, streaming is great, but FM radio is a linear service, and man, you can't beat the sound of it if it's done right. And that's everything from the microphone out to the antenna, including the antenna. So that's, for me, this is just the second chapter. So anyway, it's been a long time, but had fun along the way. Thank you.
Thank you, Bob.
Thank you, Bob.
We're going to move this ahead fairly quickly to make sure we do have time for questions afterwards, because I know there are going to be some. Herb Squire is our next presenter. Herb worked for many years at WQXR, the radio station of the New York Times. And he has been part of our groups before. This is sort of part of an informal series that Dave has done over the years that I've had the pleasure of being involved with, including the anniversary of the Armstrong FM system and a panel that we did a few years ago on the anniversary of FM stereo. So this sort of fits in as a piece with that. I think, Herb, you were part of the FM stereo panel too, weren't you?
Yes.
Yes, you were. Herb Squire.
Okay. This is a test? Okay. Yes. I thank you very much. My experiences in radio have been very varied over the years. I mean, I've been in the New York market since I got out of college in 1967, and WWOR AM radio was most of my doings for my first 13 years in the business. But I also was involved occasionally with engineering with TV and WOR FM, and I went up to the transmitter site where the FM and transmitter and the TV transmitters were located on the 83rd floor, and a few times went up to the mooring mast, went up, walked through everything, and I still remember one of those early days going up the ladder, going up to the top of the hatch to go up by the antenna, and I see this scribbling on the wall saying, "Fay Ray was here." I haven't seen it in recent years, but that was there, so anything is possible. And to change the perspective on this, I mean, we know all about the technical issues and how things went with the master antenna. I do want to say a couple of quick things. Back when I was chief engineer at WHN, which was 1050 AM, Brian Moores, our general manager, had a discussion with one of the ed agencies in town, and he had a technical question because the guy said, "I just bought this great Sony audio stereo system for my office, but I can't get any FM reception." And I call people, they try to add some equipment to it to try to make it better and so forth. So he said, "Can you go over it, maybe just give him an idea, maybe something is done wrong?" I said, "Okay, fine, I'll go over." Went over to this office, which is over around, I think it was 3rd Avenue in the low 50s. It was in a building that was many stories up. I think it was somewhere around 18 to 20 floors above. And the guy's got this receiver in his office, nice window view. The radio is on the windowsill. And, well, behind the radio, if you look out, it was a southern exposure, and there was, guess what, the Empire State Building, right back in front of him. Now, he tell me that, yeah, he came in and then he went, I think it was to Radio Shack or one of the little businesses there, and said he was getting static and noise on his radio. He said, "Oh, you need a preamp, you got a weak signal." And so I looking behind there, sure enough, with twin lead connected this little preamp that I'm thinking, looking at the antenna sticking out by the window, that this preamp is going to go up and smoke at any time. And I'm looking and I'm saying, I wonder. I just connected everything to the back and I got no reception at all. So I asked the people, I said, "Could you give me something? I need to work with something here." He says, "Can you give me a paper clip?" So I took the paper clip, opened it up like this, and put one on one of the terminals on the back, screwed it in. Bingo. He had great reception. All the New York FM stations were loud and clear. Going out to Long Island, to New Jersey, he was getting second adjacents, no problem. So at this point, I realized there's something very interesting about the propagation of FM radio, and that when I went over to WQXR beginning in 1985, when Dr. Sumi gave me a call at WHN saying, "Hey, Herb, I'm thinking of retiring. You want my job?" I said, "Well, okay." It's like I think, well, waiting for the punchline. He says, "Well, make me an offer." I said, "Well, make me an offer." He did. The rest is history. And I worked there for over a year, almost a year, as an engineering supervisor in the union while Doc was still there, because he wanted to make sure that I was totally trained on the facility, both AM and FM, so that I wouldn't go into a site cold and not know what to do. And it worked. So by the time Doc retired in April of 1986, I knew pretty much backwards and forwards the antenna system. I knew the transmitters and everything else, and the studios in the New York Times building at 229 West 43rd Street. And so I began to learn about the WQXR listener. They were a group of people that were very dedicated. We called them, the biased audiophiles. They, would accept nothing but perfection. And, if it was, problem with a scratchy record or noise on a remote broadcast, they would be complaining. And if they didn't get satisfaction, they would call up higher in the corporation. I would get calls from Punch Salzberger, the chairman of the board, saying, "Hey, Herb, I got a call from a listener. What's up?" I said, I would give him the story. He said, "Oh, okay, never mind. That's what I figured." We became very good friends that way. I also worked on his hi-fi systems as well. But in things, before I go one extra step here, one morning, I'm in my office. This is probably somewhere around 1987. And I get a call from the receptionist who says, "Are we having any transmitter problems?" I said, "Not that I know of." He says, "Well, I got 3 calls from listeners saying we're off the air." What? Did they say AM or FM? I said, "Well, they didn't say." So I figured, well, let me go. I had my radio, the FM radio on in my office. So I went in the master control room and looked around, checked the modulation monitors. They were twitching normally. And I went to the remote control, the old Mosley remote control, and went through the buttons, and readings were right. Then I went back to my office and checked with my portable radio and just to make sure that, the external antennas were getting a good signal, and maybe there was, an attenuation somewhere where something was low power on the antenna system. I didn't know what was going on. And then they would come, and I got another call saying another dozen people called. I was saying, what in the world is going on? I mean, this didn't make any sense. So I figured, well, maybe there's a problem somewhere in the band. Let me see if everybody's on the air and everything. I go up and down the dial and checking all the frequencies. And finally, at this point, I get to 104.3. And guess what? WNCN was off the air. WNCN listeners were listening to WNCN and thinking they were listening to WQXR. Later on, I checked with Rick Chicozio, and he told me that a piece of 3-inch transmission line blew at the transmitter room, and they were off the air until they fixed it. And they were off the air probably for an hour or so. But QXR probably got maybe 30 or more phone calls. So it makes one wonder about the rating systems. Did any of those people have diaries? And, what would be, QXR would be getting credit for being off the air in this particular case, but other times they were listening to NCN and QXR could get credit. But then again, things have changed, and that would never happen today with the PPM, the Purple Peter meter, the Purple People meter, and thinking of, was it Sheb Woolley, 1958. Now, one other thing I do want to mention, there was an issue that I would get calls from listeners with legitimate reception problems, and most of it was multipath. And what happened was I started listening where the calls were from. They come up the middle of Manhattan, down toward Connecticut, and down into the Rockaways in Queens and Brooklyn. There were more calls than others. And what I did was I figured, let me see. I know that the Alford antenna has issues, it has, 16 elements in a circle. And there are peaks and nulls, as you saw before on the graph. And so what I did was this is before computers. I took the image of the horizontal pattern at 100 megahertz. It was the closest in frequency to QXR, and I made a transparency of it and laid it on a map of the New York metropolitan area. And sure enough, I found that where all my listeners were that had listening problems with severe multipath were where those nulls were in the pattern. So that was also a supporting factor for why we really had to consider a new antenna. And I thank you all very much.
I worked here in the 80s and for a very short time because I determined something very, very life-changing. I hated RF, but I loved audio. But I also got to meet some of the greatest engineers in the world working in this building. And one I want to bring up now, and I'm going to do it without any preparation, and he's probably going to hate me for it, but Frank Foti made his name coming here into working at the Empire State Building and putting HTZ on the air. And after all, we have some of the great engineers from the 80s and 90s here. And I just want to say one thing before Frank goes on. There's a lot of engineers that were really great that are no longer with us, like Doc Masumian, Joe Laskar, and many others. And without them, no, FM really wouldn't have succeeded in this town. Frank?
David, thank you. I've had the opportunity to go from worst to first, not once but twice. Once was in this building at 100.3 megahertz. Actually, I think I have something here I'll share with all of you because I think it's appropriate for our event here tonight. The second, and meanwhile, while I'm digging it up, the second time I got to go from worst to first started about 5 years after Z100 was when I started my audio processing company, which is now known as Omnia. And it started in 1988 with me and one big black cat by the name of Vito Corleone. That's true. Vito was here with me in Jersey Jersey, New York, when we put Z100 on. I'll tell that story here in a moment. And then today I'm honored that we're now the leading audio processing company around the world. But speaking of which,
Serving the universe from the top of the Empire State Building. WHTZ Z100, New York.
what's that? Yes, it is. True story. I get to New York fairly often, and there are a couple times I forget to put the ringer on silent. I don't like to be, let the world know that the guy's getting a phone call, and I'll be like sitting somewhere on the subway or and that'll go off, and people turn around and they think But in any case, a couple quick things. I was part of that group that Bob alluded to where the building wasn't real happy about the fact that they were going to add a 12th radio station to the system. And that's when I got to meet Tom and his dad and Bob and John Banks and the whole committee. I also remember being, the company I worked for was a bit of a maverick company known as Mulray Communications. And they came into New York City and they decided that we're going to put this thing on the radio no matter what, and we're going to hit this deadline of August the 2nd, 1983, no matter what. And at the time, our corporate boss, Tom alluded to him, his name was Tom Brisanovich. Tom had a way of like being a bull in a china shop, and he offended a lot of people. And Tom, after he left New York, myself and our general manager, Dean Thacker, I remember having to attend a meeting at the office of Mr. Bob Tinker, who was, I think, the building general manager. And we got dressed down, if you will, as to this isn't how we do things here in New York. And we did a lot to try to improve our stature among the Master FM Antenna Committee because, I was getting to meet all these people that were, here I'm this young kid from Cleveland. And I remember once, Bob, I remember helping you once, I think, change a transfer switch or something at WKHK. And I remember thinking, man, I need to do all this stuff because of the fact of, we were the bad guys, if you will. And then, we do the whole worst to first thing. But that whole experience was very enlightening. There was a lot to be learned. And like you, Bob, I remember thinking, man, we could put all these radio stations into one antenna, and it was pretty amazing. Like Herb, I had a similar story due to the scalloping effect of the system. Our morning man and program director, who's now a channel or two up the dial at CBS, Scott Shannon. Scott was so locked into the coverage, he used to make me drive with him in a car to the Willowbrook Mall, and he had marks in a parking lot. And he'd say, Franco, I can't hear Z100 over here. And I say, I know, Scott. And then, but I can hear PLJ, which was our competition. And then I would drive my car or drive the car over 3 other parking spots where we could hear Z100, but you couldn't hear PLJ. So the whole thing about coverage and things of that nature was, very interesting. Something that I heard when Tom, you were talking about the whole thing about 75 kilohertz bandwidth. I'll never forget that, because it's always been probably the most competitive market with regard to sound, there was a time where something had happened, we had to shut the Alford off, and we were at the time one of 3 stations. There was ourselves, RKS, and NEW. We each had a backup bay out on the ice shield, and we'd switched over to the other antenna, and I remember everyone thought that I tweaked the processing because the bandwidth of the antenna and everything was so much different. And remember the fact that 100.3 had to go through all those cavities all the way up. And I used to wonder, like in the dead of summer, when the heat, on those E levels, no, really, I mean, with the expansion and contraction of the heat, how much did things change? And did we ever really know one way?
We never told you, Frank, but you were at about 10% power.
But we were still #1 in the ratings. So, one last quick story, and it kind of sort of ties into the FM antenna system. Many people may know that Z100, from its inception of August the 2nd, 1983, was a very competitive radio station, and there was no love loss between our radio station and a radio station at 95.5. And when we went on the air, we went on the air, let's put it this way. If the folks from the Federal Communications Commission were around, they would have probably been writing tickets like crazy because we didn't have a remote control system, we didn't have a mod monitor, we had a lot of nothing, okay? And so the only way I could set modulation was we had an old Marantz tuner that had a composite output. And being out in the Meadowlands, we had a great signal from New York, very little multipath. So I would, scan the dial, and I'd look on the oscilloscope. I'm looking modulation. All of a sudden, I'd see one set of peaks that went way up. And I'm like, wow, man, I wonder, somebody must have misadjusted something. And it happened to be our competition. And I remember thinking, if they get to go down to the corner store and get free bottles of pop, I'm from the Midwest, I need to get some bottles of pop. So we decided that, I remember the general manager saying, you do what they're going to do. Well, eventually there became a modulation war in this town. Oh, I know, who was laughing? Yeah. And it was at an AES, actually. It was at an AES convention, back when they used to do it over, was it the Hilton or the Sheraton? The Hilton, right, New York Hilton. And at the time, Mr. Robert Orban was introducing the first loudness meter, okay? Believe it or not, even though our companies compete, like the Ohio State national champion Buckeyes and that school up north, what's it, Michigan, is that it? But in any case, Bob was showing this meter, and somebody from the FCC happened to see it. And I learned of this story from Mr. LeBeau here, where the FCC said, Bob kept wondering why was his meter pinning, because he felt that from a tuner it should be peaking at a certain level. Well, a gentleman from the FCC realized that everyone in New York was pushing the modulation, and the rumor was they were going to give everyone 2 weeks to turn it all down, or they were going to write fines. And we ended up getting basically all the engineers from New York together for lunch one day to talk about turning the modulation down. And the lunch went real well until it ended up being a shouting match between the chief engineer from 95.5 and 100.3 because we were so competitive. And I think that was the day that I became good friends with Bob Deitch, because we were so focused on being the best that and wanting to beat the other guy, but we had a lot of respect for one another. The last thing I'd like to say is that I started my little talk, ad hoc talk, and thank you, David, and the SB and the AES for allowing me to speak. Is that I mentioned I went from worst to first twice. If I didn't have that opportunity to do that here, I'll tell you that there is no Omnia audio processing at all, because basically what I was able to do was package what we did with a lot of love back in Secaucus, New Jersey, and turn it into a product. Excuse me, I'm popping my peas. And it served me well. So I have a lot of affection for this city, all of radio here. I mean, I know I mentioned Z100, but you know, I've had the opportunity to do business with just about everybody in New York City. I thank all of you, and there's always be a special place in my heart for this building. Thank you.
Go blue.
Just remember who the national champion is.
Yeah.
And by the way, we don't give it up on the last play.
Yeah. It's her family that's the mission. Anyway, I went to Brandeis. We had no football. Yeah. One of the reasons that I'm here tonight, I'm not an engineer. I describe myself as a news guy who has learned to speak fluent engineering over the years. But one of the reasons that I'm here tonight is that people in radio typically are not good at saving things. You're on to the next thing, you're on to the next format, you're on to the next promotion, and stuff doesn't generally get saved. And so one of the things that I really enjoy doing is meeting people who have saved stuff over the years. And one of the people who's been incredibly helpful to us tonight making all of this happen and getting us some materials that we needed is, I think, probably the only full-time archivist working for any individual radio station in America. He'll correct me if I'm wrong about that, but I don't know of any other. Andy Lancet is the archivist downtown at WNYC, and now at sister station WQXR. And he's got a wonderful facility down there. They have a wonderful history that's been collected and saved over the years. And I want to bring Andy up to say a couple of words about what he does and a little bit about some of the history that he's helped collect over the years.
I really appreciate being here tonight. It's quite an honor. As you may know, WQXR was the first station broadcasting over the Alford in 1965. And of course, WNYC came along around September of '66. And we're here through, let me think, October, I believe, of 1986, before we went down to that other building downtown. And came back again in 2002. But I wanted to thank Scott for the presentation tonight. I've certainly learned a lot, and we've got a lot of paper to go through at WQXR and NYC. One of the nice things about acquiring WQXR, as we did in 2009 rather, is that Doc Masumian and his successors kept everything, and we've got boxes and boxes and boxes of material that we're still going through, and we will be for a while yet. But we're really thankful that Herb Squire and his colleagues held on to this stuff. And we look forward to getting it up online and making some of that material available to folks like you as soon as we can. Thank you.
One thing I want to bring up is I was a really young engineer in the 80s, and a couple things happened, and a couple of you might remember that Channel 68 waveguide fire. If you remember that, the whole building was evacuated. Everybody's standing around outside. Of course, I was working for Jim Stagnito at the time at WNSR, and all the engineers are standing outside. The firemen are getting ready to go in. And Frank Tuviolo at the time was head of the master, and I'm not knowing anything because I was a young kid, and Tuviolo comes up to the engineers and goes, "Who wants to go up with the firemen?" Okay, I'm stupid. I go, okay, I will. And so we're going in there. The firemen are all, wearing all their protection and everything. I'm a stupid kid in jeans and a T-shirt, and Tuviolo goes to me, "Don't open the door if it's hot." That was the only warning I got. So went up there, and everything was safe, and then I'm sitting up in the diplexer nest because all the stations are down. John Lyons and Paul Sanchez are with me, and Lyons and Sanchez start opening up everything because they had to separate the Alford into because they were only going to use one ring. I was totally amazed that these guys could do this. It was an amazing thing. And what also amazed me is that, yeah, there was a master antenna committee, but all engineers, we're a team and we help each other out. And more times than not, like after that happened, every engineer had to retune our transmitters. If you remember Matt Connor, he came in with me and helped me retune my Harris 25 because, of course, my engineer was out of town. And like I'm saying, okay, I know what I'm supposed to do, but I have never done this before. And damn, this is New York City. So, a 21-year-old kid is scared to death about that. But it's really great that all the engineers in this building have always worked together. And whenever you say you need help, no one ever says, no, we're going to let you burn. I mean, I can't tell you how many times I've called Herb on for different things, and we've always worked together. And that's the great thing about the New York engineers. We're always a team. And I just wanted to add that.
Thank you so much, David. I have not been outside to see the state of the cake, so I'll depend on Shane and Peggy to let us know when we've got to wrap up the questions and answers and move on. Okay.
Just raise your hands and I'll bring the cordless mic over, or a wireless mic.
We've got a question back, and as Dave is working his way back, we have another surprise for you tonight. Actually, two of them. To thank you all for coming and being part of this historic event tonight.
Okay, we have Bob Katz wants to ask a question.
All right, hang on a second, Dave, so we've got to announce the surprise first.
Okay.
First of all, at the end of this, you will all get passes to go upstairs to the 86th floor observatory and check out the greatest view in the city, thanks to Shane in the building. So, question.
Okay, before we go on, I just want to remind everyone, if you have any comments or suggestions, email broadcast@aes.org, and we really have to show a little more emphasis to the AES that broadcasting still matters. So please send in emails, because I send it to them, because they keep saying to me, oh, broadcasters don't care about the audio. So let's show them differently. Okay, now Bob Katz.
I'd like to ask any of the engineers what you do about connector corrosion.
Ooh, that's a rotting question.
You want me to answer that?
Go ahead.
That sounds like a Tom question.
Does this mic work? Yeah. I assume you're referring to connector connections outside of the building, is that right, or are you talking about inside?
Any connections, coax, audio, whatever.
Usually the problem you have is not so much the connection. The connection in coax has a Teflon insulator and a bullet. And the problem with coax is that the inner conductor and the outer conductor over temperature move at different distances over time. Coax is rated at if you run coax at rating, like 3-inch rigid lines rated at 56 kilowatts, and at that rating, the inner conductor runs at 212 degrees centigrade or 212 degrees Fahrenheit or 100 degrees centigrade. So what happens is that the inner conductor is really hot, but the outer conductor is not as hot. So whenever you make coax, you always make the inner conductor about maybe a 1/4 inch shorter than the outer, so that as it heats up, it moves out. So what happens is that over time, the real problem with coax is that the inner conductor moves back and forth on the bullet, and eventually it galls, and you get interconductor failure. So like at ERI, I never run rigid line, 3-inch line over 40 kilowatts. We always derate the line. 6-inch line, I like to run it under 125, even though it's rated at 180. I've run it at 150, but I don't do that. So the Empire State Building rigid lines are run very conservatively. The filter has never burped once. It now has 16 stations on it, I believe, Shane. and it's the largest FM combiner in the United States of America. The combiner, the old combiner, had 3 dB attenuation, 75 kilohertz. The new combiner has roughly a roll-off of about 0.2 dB at 200 plus or minus 200. And when we turned that combiner on, the Empire State Building new master was actually implemented not so much to improve coverage, but to reduce radiation on the tourists 186, thanks to Rick Tell's work with the new standards on radiation exposure. And Neil Smith and then now Kevin Fisher take the measurements on that area. And when it was turned on, nobody expected the coverage to improve, but the coverage improved significantly because of the bandwidth of the filter. Is that right, Bob?
Yeah, let me just add that the other thing that, is this thing working? Yeah, it is. The stereo performance and subcarrier performance was dramatically better with the new antenna. And that's largely because we put a very stringent, if you remember, we put a very stringent specification in for envelope delay, group delay. And if I remember right, it was plus or minus 25 nanoseconds. And you know, both the bandwidth and that group delay correction, and we put group delay correction on every module, whether it needed it or not. And as we have all these 800 kilohertz spacings, but the sound, just the plain audio quality was so much better, and the subcarrier performance was better. The subcarriers, you know, were a revenue were then and still are a revenue source for these stations, and this was all made practical. And this was the learning experience and the learning curve that we had with the Alford system. You know, it was great in its day, but you know, so many more improvements were made in the late 60s and the 70s and even into the 80s. Going from notch combiners to constant impedance bandpass combiners, almost universally used today, especially for 800 kilohertz spacing. So yeah, it's, you know, it's not just about the RF, the audio, and that's why we're here. I mean, this is the Audio Engineering Society. The audio was so much better.
So going back to the question, you don't really have problems typically from the outside unless someone steps on a flex line, which had happened one time and caused it to fail. There's been a lot of climbers going through that product, and it's really tight in there. But the real problem with coax deterioration is on the interconductor on the bullets, and that's where it usually fails.
Okay. More questions?
Please raise your hands.
No more questions? We've got one up front here. Up front.
What happened on 9/11 with the transmitters? The switching between what happened?
The 2 buildings fell down.
Yeah.
Your question.
How long did it take you to bring everything up here?
As you know, the airlines shut down the airspace for 5 days. On the 6th day, Ed Carter and Ed Carter is the guy that I normally work with on this building. We did the CBS work on 81 in 2008. We did the FM Master Antenna in 92, and we moved in the building in November 15th, and Ed worked with me for many years. At the time, he was with Jimmy Grapp, and I was an independent contractor. So after 9/11, Ed met me in Chicago on the first flights that flew, and we went to Andrew, and we worked with Dielectric as well to go through some antennas that were going to be shipped to the building. Jampro was involved as well. And then Ed and I were scheduled, once we went through the training at Andrew, because I own that product line now, but at the time it hadn't been sold yet. And so Ed and I then, on the 2 days later after we went through training, we went out to Midway and flew to Newark because LaGuardia was still closed, as everybody knows. And when we went out to get on the plane, the pilot came out and looked at us and he goes, what are you guys? And we said, well, we're iron workers and engine. And he said, you want to sit in first class? So he put us right in the front. He said, if anybody bothers me, you tackle them. And I said, drinks are on the house. So we flew in first class to New York. And then when we got to Newark, in those days you took the bus. And when we drove in the city, the terrible sight of ashes when I was scary, and we were working nights. And then we started on the Viacom building and built a Channel 2 backup. And then we went downtown and we were
You
doing...
did a two-station combiner there, too.
A
for
two-station,
FM,
yeah. So we scrambled. I think I worked in New York for about a month, and then...
How long did it take to get all the stations back up?
Well, on the first station that went back, that came to the Empire State Building, I talked to the group about it, and I proposed a filter. And Joe Giordino didn't like it, so he bought a Shively four-pole passband. And he said, "Why did you want such a fancy filter?" And I said, "Joe, you don't have a broadport anymore." And he goes, "Oh, shit." So that filter's, I think it's still in the room somewhere.
Yeah.
So what we ended up doing was we started scrambling, and the way we designed that filter was when we first started working with Bob Tarzio, and Bob insisted on coming out and doing measurements, thank God. So they brought a modulation monitor and an exciter out, and we built 3-pole filters. But what we realized was that 800 kilohertz, a 3-pole filter won't work at FM, so we immediately went to 4 poles. So, but to make it work, we biased the filters so that we went from one end of the band to the other, and they were all in line. So when we had to add when we originally designed it, it was supposed to be 11, but Bob and I talked about it. The 12th guy was negotiating, so we went ahead and designed it.
104.3 WAXQ never came on the system originally, but we went ahead and put the filter in anyway.
And then they came on. So we had the 12 stations in line. So in order to add the other 4, Robert Rose and I looked at it, and we figured the best way to do it was to break into the line. So what we did was, the way the filters are set, they stacked vertical. And you can go upstairs and look at them if you want. I mean, we can take you up there, I guess. But there wasn't enough room. So we stuck them vertically, and on the bottom of them, we had like a Z-link that goes through them. So we broke into that Z-link, and every station we added, we put into the proper order that way. And that's how we got them in there. So we ended up putting, like if you go in the building, if you go in the back of the building, there's 4 filters jammed into the corner on the southeast side of the room.
Still on wood pallets.
Yeah. I did what I had to do.
But they're in the right order.
But they're in the right order, and that's how we did it.
I want to remind everyone that in 2003, for the AES, I organized a session called The Rebuilding of New York, where Tom went into detail with all the other engineers on how they did rebuild all the broadcasting in New York. And we do repost the audio from that session every year before 9/11 in memorial of the engineers we lost. So you can get it. It's usually on the AES Facebook page, and also just Google it. It's out on the web, and it's really compelling audio.
You know, it's funny. I was driving to work that morning, and my phone kept ringing. I had a cell phone then, and people would say, "Hey, what are you up to?" I'd say, "I'm driving, nothing." "Where are you? Are you in New York?" "No, I'm in India." "Oh, great. Okay, just checking on you." And a minute later, I get another call. "Hey, what are you doing?" Because Robert and I got hired to evaluate the combiner system for FM in the Trade Center, because everybody had forgot how it worked and nobody knew how it worked. But it was the weirdest filter. It was a combination of notch combiners, passband combiners, and runout combiners. So we detailed it and figured it out and wrote it all up, and then we added a station to it. And so everybody was wondering if I was dead. But, it was a terrible time, and I knew many of those engineers, and I've always mourned them. One of the greatest lacrosse players from Cornell University was killed that day. And he is remembered at Cornell every year. I was a Cornell lacrosse player for 4 years, 35 wins and 1 loss. But such it is. But anyway, it was quite an event. We also did the VHF, Ed and I did the VHF TV antenna. We replaced the VHF antenna again. We replaced the Harris UHF antenna with the dielectric one that Andre Scalina designed. And we did the brackets for that. And so we've had a lot of history in that building, all since 9/11.
Yeah, it really was a remarkable. I was covering a lot of that. at the time, and just antennas moving back and forth and going up to Alpine and going up here. And it's remarkable how much has been cleaned up from that. It was totally coincidental that in my calendar for next year I had a picture of Empire from a few years ago, and it's nearly unrecognizable compared to what's there today.
I
So.
hope I get one of them.
Oh, there, Lisa's got them out in the lobby.
Let's not forget, there are two FM combiners on this
Yes.
building. The Minimaster, which is also an ERI project
That serves
we
the
did.
3 stations that never went on Alford.
Yeah.
And with that, I think we've got to wrap this up. We have cake waiting for us outside. Thank you so much to our hosts here at Empire. Thank you so much to David and to Peggy, who have worked so tirelessly to make this all possible. I can't even
And thank you to Scott Fybush of Fybush.com and the Tower of the Month magazine. Calendar.
Well, that was fascinating. I love that whole presentation. I was there, sitting between Frank Foti and Chris Tobin. So, hey, it was quite a fantastic evening. I hope that some of you were there and got to relive it. And if you weren't there, well, you just now got to see what was going on. I'm Kirk Harnack, and I do want to thank our sponsors again, the folks at the Telos Alliance and Axia's Livewire Plus, AES 67 compatible, and compliant, I should say. And Axia Livewire Plus is partnered with a ton of companies that'll help you just plug your studios together. Also brought to you in part by the Telos Alliance and the Zipstream R2, which is a 1-rack unit, 8-program audio processing and streaming appliance. It will handle your needs. It's like 8 transmitters in one. And also by the folks at Lavo and the Crystal Clear virtual radio mixing console. A Crystal Clear is the console with a multi-touch touchscreen interface. Thanks a lot to Chris Tobin. And thanks to Jeff Schick, who worked on the video so hard and supplied that. Also thanks to Suncast at the GFQ Network for producing this program. And thanks to Andrew Zarian for making the GFQ Network. I hope you'll tune into other podcasts on the GFQ Network. There are some really, really good ones, and I enjoy watching it quite a bit myself. Well, that's going to do it for us and for me, and thank you for watching. We'll see you next week on This Week in Radio Tech. Bye-bye.